And I have these broken down essentially by size. So we're starting with any polynomial, and we only have one way of factoring any polynomial. This doesn't necessarily always work, but it could possibly work on every single polynomial. Do you guys know what that one factoring method is? Phil?
GCF?
Yes, so factor by GCF. This might work on any single polynomial, right? It's our only method that could work. And that's actually what we did in the warm-up today. We checked, we found that one of our problems did have a GCF, so we need to make sure every single problem you go through, this is the first thing you do. It takes what? 5 seconds tops just to do a quick check. Is there a common factor? Right? So make sure you guys are always doing that. Do this on every problem. So check on all problems. All right, so after that, this is the first thing you always do. Once you have identified whether or not there's a GCF, a greatest common factor, then there's only a few factoring methods we have. So let's break them down by size. So if we have a binomial and we've already taken care of any factors, common factors, we only have one method here. We did it today in class. You guys know how we can factor, Patrick?
Difference of perfect square.
Yes. So this is our difference of two squares. This is our only way. So this is our a squared minus b squared, and this becomes a plus b, a minus b. So once you've taken care of a common factor, if you notice you have two terms left, right? Binomial means two terms. If you have two terms left, you should go right to, is it a difference of two squares? If it is, you can keep factoring. If it's not, you're done. Yes?
So if you have a plus b like squared, and that's not factorable,
Yep.
you just say not factorable.
Yep. So if you got a question, I don't think we've had too many, x squared plus 9, sum of two squares, your answer would simply be not factorable, right? There's nothing you can do there. Our only method for factoring this, there's no common factor, and it's not a difference of two squares. So we would just simply stop and say not factorable. Yeah.
If I had like x squared plus 18x, would it be factorable?
Yeah, you could take out an x, right? Then it would be a GCF problem. All right, our next one, trinomial. We actually have three things here. So this is this is what we spent most of chapter 8 on. So let's make sure that we get all three ideas down here. So the first one is we looked at without. So without leading coefficient, that was the first thing we looked at. And I think one of the first problems we actually looked at was x squared plus 7x plus 12. And all we did was we found two numbers that multiply to 12 and add to 7. That was how we factored this one. These are going to be our easiest problems to factor, right? You guys are hoping you get trinomials without leading coefficients as they're the easiest ones to factor. We simply look at this number, what multiplies to 12, adds to 7, right? Or whatever the combination of numbers is. That was our first method. Our second method was factoring with a leading coefficient. So this was without. This is with a leading coefficient. And one of the problems that we looked at was something like 5x squared plus 7x plus 2, where our method was a guess and check, right? Method was guess and check using, we undid FOIL. So for example, when we're filling in our binomials, what goes in the first part of each binomial are the two numbers that multiply to 5x squared, which we know are 5x and x. And then we'd go about checking the L part in FOIL, the last, and keep filling it in, right? That was our guess and check method. And then lastly, for a trinomial, we had a perfect square trinomial, also what we looked at today. Perfect square trinomial, and our pattern is a squared plus 2ab plus b squared factors into a plus b squared. And this is just where we ask ourselves, are the first and last terms perfect squares? And if they are, we write in our answer and then check. Are the first and last terms perfect squares? Yes?
Can you do, the second one, like 5x squared plus 7x plus 2, can you factor that?
Yes, you want to go through that one? Sure. So to get an example of this, what we want to do is we're going to fill in a binomial, or two binomials, I should say. And let's see what happens with that. So as we start filling this in, we're going to have blanks here, and then we're going to start with 5x and x, because these two multiply to 5x squared. Then we are checking the L part in FOIL, which multiplies to this 2 right here. So what numbers multiply to, everybody?
2 and 1.
2 and 1. So you either can 1, 2, 2, 1, right? And then we simply check the O and I parts in FOIL, and if we do that, we should find that we're going to end up here with a 1 and a 2 with both positive, because if we check, we're going to get a 5x plus 2x equals 7x, and that works, right? That's our guess and check method. And then finally, those are all, that's what we spent most of our time on, was trinomials. And then a polynomial with 4 terms. We only had one way. What was that way, right?
Factor by GCF.
We already talked about GCF, right? Grouping. Everybody, is there a common factor in part A? This should be an overwhelming
No.
no. Yes, it's very clear there's no common factor. So, volunteers. Anna, how do we do it?
4x plus 3 times 4x minus 2.
Difference of 2 squares. Alright, next one. Is there a common factor?
Yes.
Okay, someone raise your hand and tell us what it is and what happens when we factor it out. Ryan?
Common factor is 5, and so you're going to get x in second plus 7x plus 12.
Alright, somebody else factor this. Now remember, we have 3 options with a trinomial, and I see no leading coefficient. Nelson, what do we do?
We see which ones add and multiply, so I got 5, and then x plus 3, x plus 4.
There you go. Alright, everybody, is there a common factor in part C?
No.
Yes or no?
No.
No. Alright. So we have 4 terms. Someone raise their hand, tell us how are we going to factor this one? No?
You group the first 2 and second 2.
Okay. Do you want to keep going, or are you just letting us know?
So then you would divide 4 by 16 and 40.
Is there a larger number than 4?
8.
I like 8. Okay, what's left over?
It'd be 2x minus 5.
Awesome. Now, somebody else continue what Noah started for us. Liza?
And then on the other side of the lower, it's 7 times 2x minus 5.
So you didn't take out a 7, you took out a...
I took out a 7, but that was negative.
You had to have taken out a negative. Yeah, negative, you just did it without even thinking. And then finally, someone else finish it. Whoa.
It'd be 8x to the second minus 7, and then that one times 2x minus 5.
Thank you. All right, is there a common factor in part D, everybody? Okay, what is it? Okay, negative 5x, and we're going to be left with an 8x squared plus 3x minus 4. Now, I believe this is our final answer. We can do a quick check of that. So if we could keep going. This would be a very challenging trinomial with a leading coefficient problem because of the 8 and the 4. So we know our options for 8 are 8 and 1, 4 and 2, but then our options for 4, we have 1, 4, 4, 1, and then 2 and 2, right? So we have all these different combinations, and we're getting to a 3 in the middle. You can check them out. So I would first try the 2 and 2, as you don't have to guess which one goes where, right? And then you can just fill in. So it wouldn't work with an 8 and a 1, or even a 4 and a 2. There's no combination there that works, so we know 2 and 2 is not an option, right? You can check the 1 and the 4, same thing. The 1 and the 4 won't work. And because all of the, really what I'm getting at is all these are even numbers, right? Except for the 1s, but if they're being multiplied by evens, you have no combination that will ever get you to a 3. So because of that, you have all these even numbers and you're trying to get to an odd, it's not possible, which leaves this as your answer, which is a perfectly acceptable answer. Right? Yes.
Actually, no.
Okay. So this is it. This is just a GCF problem. It looks like it's a trinomial problem, but it's not. It's just strictly a GCF problem. Alright, so let's keep going. Do we have a common factor in part E, everybody? No. Okay, so then we go through our trinomial options. It has a leading coefficient. Patrick, what were you thinking?
2x plus 3 squared.
It's a perfect square trinomial because the first and last terms are perfect squares. So write it 2x and 3, and let's just do a quick check. 2x times 3 is 6x, doubled is 12x. So yes, we did this one correctly. And finally, everybody, is there a common factor in part F? No. Okay, it's a trinomial. It has a leading coefficient. Is the leading coefficient a perfect square?
No.
No. Okay, so then our only method is our guess and check option. We know that this is definitely a 3x and an x. We know our signs are going to be opposite, so let's fill those in later. What numbers multiply to 16, everybody? 4 and 4. What else?
8 and 2.
Okay, I would check 4 and 4 first, even if it doesn't work, just because you don't have to guess which goes where. So if you plug in a 4 and a 4, you get a 12 and a, well, it's not good. It's going to be too small, right? We find that out pretty quickly. To get to a negative 22, I'd guess an 8 here and a 2 here. And as we check, we get a 24x and a 2x. We need our larger here to be negative, so negative 8 plus 2. We did it correctly.